BMO, the Berkeley Mechanical Oscilloscope, is the world's first automatically adjusting mechanical oscilloscope. BMO uses a 300 milliwatt laser and two actuated mirror assemblies to intelligently visualize audible monophonic waveforms. In this way, BMO emulates the behavior of a traditional oscilloscope using mechanical parts. BMO's anvil case has standard connectors for power, signal in, and signal out. BMO can display arbitrary waveforms, so it can be driven with any function-generating device. Wait, Grant! That function generator is totally boring. What you need is this function generator. That's right. And while we're at it, let's get you some cooler glasses. Tight. Now you're ready to jam. Turn off the lights and start playing. BMO is controlled using a physical user interface divided into input and output panels. The operator describes the desired display mode using the input panel, while the output panel describes the current display mode through the illumination of four symbols. The display mode is defined by the state of four settings, which are amplitude, creep, laser pulse, and symmetry. The illuminated arrow indicates the strength of the creep effect. The projection can be made symmetrical by displaying an odd number of peaks or valleys. In the past, computers, control systems, and media players were purely mechanical devices. The original purpose for BMO was only to be an artful demonstration. That is, it would prove the continued capability of mechanical engineering to solve a variety of interesting problems. However, we have found that this portable and rugged machine is very capable in its own right. It would be very useful as a piece of stage gear or even an educational tool to illustrate the interesting nature of nature. If you would like to learn more, please visit our website.